आओ। कितने लोग हो तुम? क्या हुआ? हाँ, पढ़ो, बता रहे हैं। नोट।
हेलो, हाँ पांडे सर, गुड मॉर्निंग।
हाँ, मॉर्निंग मॉर्निंग डॉक्टर प्रमोद।
Pandey sir, shall we start, sir?
बिल्कुल, we can start now.
Okay.
Let other-
So, very good morning to all the participants and faculty members. Welcome to the second day of this course on drought and flood management. So today's speaker is Dr. H.K. Pandey sir. So I'll just brief about him. Sir is presently an associate professor in the Department of Civil Engineering, MNIT Allahabad. He completed his BSc and MSc in geology from BHU Varanasi. Further, he completed his PhD from ISM Dhanbad in the year 2000. His core areas of research are groundwater exploration. His core areas of research are groundwater exploration and management and engineering geology. Sir has been awarded with BHU Gold Medal and Professor Rajnath Gold Medal during BHU in Banaras Hindu University. Before joining this institute, Sir has also served on the post of Scientist D at Central Groundwater Authority Board, Ministry of Water Resources, Government of India. For his service there, he was awarded with the letter of appreciation from Ministry of Water Resources, Government of India. So now I request Sir to start his session. Pandey sir, please.
So thank you, Dr. Pramod, for your kind introduction about me, and very good morning to all of you who have joined this course and attending the class. Uh, Before sharing the PPT, just I would like to have certain discussion among the participants that if we are deliberating in the English mode, whether any participant is having any problem, so please convey so that we can convey to the other speaker also, and myself can adopt the mixed language for the communication. So if any participant feels difficulty in the English mode of communication, then certainly let us know, so that the real objective of this 5-day short-term course is reached to you. Secondly, as my topic is the application of GRACE in the analysis of drought or drought analysis. So as you know, yesterday you might have listened the lecture from the experts, from the speaker, that there are different types of the droughts, and among those droughts like meteorological, hydrological, agriculture and socio-economic droughts, hydrological droughts consist of surface water and groundwater both. During inaugural program also, you might have listened, if you recall back, by Engineer Vijay Saranji, that subsurface water, that is groundwater, if it is depleted, it is also a source for a reason or cause for the drought in any area. So I will be speaking in a case study, particularly applications of GRACE data for analysis of drought in Bundelkhand region. As you are very much aware that after Maharashtra, Bundelkhand is also in the forefront regarding the drought conditions, frequent occurrence or the recurrence of the drought conditions, either the Bundelkhand region of Uttar Pradesh or Madhya Pradesh. So we have selected, actually it is a small type of, you can say, short research work, findings, which just I am going to share with you, and a new approach from our side. Although you might have been knowing about the applications of GRACE, it is not very new, but certainly the approach and the how we have used the GRACE data as far as analysis of drought is concerned, or particularly you can say, if I clarify or I say in nutshell, that the depletion of the groundwater storage beneath the earth's surface at large scale without applying much more manpower. As you know that groundwater monitoring manually is very difficult in the larger area. It requires more money, more manpower. So with this application of GRACE data and using different platform and software, we have attempted that how change in the groundwater storage can be achieved or can be known. So let me share now the screen. I think my voice and this screen is both visible and audible. I am audible as well as the screen is visible to all of you. Dear participants, I request you to please confirm whether the screen is available or not. It is visible to you or not?
Yes, sir. Visible, sir.
Yes, sir.
Thank you very much. Okay. So the application of GRACE for drought analysis in Bundelkhand region of UP, as you have course schedule, and this is the topic for today deliberations from my side. It is a GRACE stands for Gravity, Recovery and Climate Experiment. It is nothing but a satellite data, and in 2002, on 17th March 2002, twin satellites were launched, one for gravity recovery, gravity field of the earth, and second is the climate, related to the climate. Therefore, it is called GRACE, Gravity Recovery and Climate Experiment. Why the GRACE provides unique measurements. Why this gravity data, how it is important for changing the variations in the groundwater, and what is the principle on which it works. If you look, it provides unique measurement of the variations in the mass. You are very much aware that the gravity is directly related with the change in the mass over the Earth's surface, producing monthly maps of the gravity field. Only one condition is there: it requires larger area. Resolution is very larger, means the area is very large, should be large, 300 to 400 kilometers. And if you are performing this set of data in a very small, suppose that area, 50 square meter or 100 square meter, or even, 50 square kilometer, then it will not, in my opinion, it will not suit as if you are selecting the larger area. These variations in gravity are primarily related to the movement of terrestrial water. In the case of changing the or knowing the groundwater is changing the groundwater storage beneath the earth's surface, then we are changing the gravity is directly related to the movement of terrestrial water, because it will affect the soil and rock mass. If the rock or soil is devoid of the water, and if it is having the water, both will be having different mass, and therefore it ultimately tells us about the change in the water thickness or terrestrial water storage, TWS. TWS will be again coming again and again in the formula. Just I am slowly moving, and then you will find it interesting. Using the GRACE terrestrial water change, with model-based hydrological components, other components, groundwater can be estimated. So let me come to directly a quantitative framework for measuring of the severity of the regional water storage deficit. As I mentioned, that on the regional scale it is very suitable. It is not so suitable on a very micro scale or smaller scale. So it is a NASA satellite gravity recovery and climate experiment satellite mission, as I have already mentioned. And the GRACE-based terrestrial water storage are available at 1 degree by 1 degree, means in the topo sheet, and GRACE assimilated GL-DAS groundwater data are available at 0.25 degree into 0.25 degree. Because of this coarse resolution of this data, two neighboring grids may not include independent estimates. This is the limitation. This point limits the applications, or you can say the accuracy. But there are certain merits. Certainly, larger merit is that without having much more manpower, without investing much more money, you can have at least 75 to 80% or 85% rather accurate analysis, or you can say the measurement of the change in the groundwater storage beneath the earth surface. And that by analysis or analyzing these type of data or findings, you can say you will certainly can reflect or throw the light that what is condition or what is the condition to be in future related to the drought, because soil moisture is very important for agriculture drought as well as hydrological drought. Groundwater is a one component of hydrological drought related to the hydrological system, and second, soil moisture is responsible for agriculture drought. So these two types of the droughts can be very well addressed by the application of this. The physics involves that distance between the two satellites, the gravity or mass concentration, you all know. Variation in the gravity observed by GRACE and interpreted as terrestrial water storage. So here is the one point, that change in the terrestrial water storage is governed by the gravity data, and gravity is being observed by under the GRACE. If you see the you can say the capacity of the GRACE, it collects 250 gravity profiles per day. And GRACE level 2 gravity products are derived by collecting data for several days, together with another ancillary data, gravity, spherical harmonics or coefficients are derived. So based on these data, mass anomaly, as you know that departure either positive or negative from the mean is known as anomaly in any area. It is not in the only related to the GRACE. If term or word anomaly comes, it means it is away from or departure from the normal or mean. So what is the, if suppose that you are saying that it is a positive anomaly in the rainfall, it means large, means the normal mean rainfall, how much it is deviated, either positive means the higher rainfall or lower rainfall. Likewise in the mass anomaly, departure from the mean mass are derived indicating anomaly to total water storage, terrestrial water storage. The monthly data can be downloaded here. It is link is given. You can download the data. That's why I said that it is not costly. No cost affair is here. Only your time and skill related to the application of the software and the, you can say the expertise, or you can say if you are well known or very you can say in the practice by operating these you can say software like ArcGIS event, then you can perform this work. And because we will be in the afternoon, certainly according to the schedule, you will be having the hands-on the ArcGIS in the application for the flood inundation mapping. So how the terrestrial water storage changes to the groundwater. So let me come to the formula, then certainly it will be very easy. Terrestrial water to the groundwater. As you know that precipitation, if you are detecting the evapotranspiration out of it and base flow, that is river discharge, then you are getting the terrestrial water balance. And if you are getting the terrestrial water balance, you are going to calculate, because it is terrestrial water balance equal to change in the groundwater storage, change in soil moisture, change in snow water equivalent, and change in surface water. So again, according to this formula, if you want to calculate the change in groundwater storage, automatically this formula comes like change in terrestrial water storage, then change in, you can say, the soil moisture, and change in snow water equivalent. I will be coming one by one how we are going to estimate delta SM, delta SWE, or delta SW. So because there are different aspects, when I am going to explain the methodology. Under that, the integration of different approach will provide all these. Besides total terrestrial water and groundwater, then other things are going to be known or analyzed from other sources. Here, the platform which we have used, it is the Google Earth Engine. And you know very much, or you are, I firmly believe that all of you are very much aware about it, that it is a very versatile, you can say, the platform where cloud computing, geospatial processing function, data catalog is also there, and process-based data is also available with Google Earth Engine. So it is a very versatile tool, you can say, a platform where we are so busy combining this Google Earth Engine and the GRACE data. We have performed the analysis of groundwater depletion in a larger scale, like entire Bundelkhand region. entire Bundelkhand region of Uttar Pradesh. So if you look towards it, we take the grace TELUS means data from three sources. One is the Center for Space Research, that is here depicted as CSR. Then second is Geofrost Centrum Potsdam, GFJET, and then third is NASA Jet Propulsion Laboratory. All these three, if we have seen and we have taken the mean out of it, this is the here the total water liquid water estimation and thickness change in that changes. Then it is giving the value which is minimum and maximum in centimeter, the variation, and out of these you are finding that they are very close to each other. The sources, these three different sources, you can select one also, but why we have selected that, we have taken mean out of it. So therefore we have chosen these three sources for the grace monthly mass grids, and so that we are taking the mean out of these, and to means you can say, so that we are very close, or our estimation is going to be very close to the realistic. Study area, I have already told to you in the beginning that the entire Bundelkhand region, where you have seen there are 7 districts: Jalaun, Jhansi, Lalitpur, Mahoba, Hamirpur, Banda, Chitrapur. And you might have listened or very much aware that out of these, Mahoba, Jhansi, Lalitpur and Chitrapur districts, they are suffering a lot from the water crisis during peak summer season. And they are also facing a lot of problems related to the drought. So we have selected this region for this analysis using the GRACE data under the Google Engine platform. So what methodology, if you see the area 29,429 square kilometer, and I have already mentioned there are 7 districts, and I have already mentioned the third bullet that meteorological drought affected area is there, because yesterday you have listened a lot about the classification of the drought. So meteorological drought, where it is calculated on the basis of departure of the rainfall, whether the negative departure is there or positive departure is there, then the drought conditions are classified. So here this region, Bundelkhand region, has already been declared many times by the state government and including the central government that these are areas which are suffering from the drought. So there are even many rivers, but due to the rocky terrain and the slope, the considerable slope, even the rainfall is not so less, but due to these two regions, slope factor and the rocky terrain, hard rock area, these two factors do not allow the runoff to percolate below the earth surface or ground surface to form the groundwater in the sufficient manner. Therefore, the topographic conditions, soil condition, rock condition, these are the important factors which are governing the occurrence and movement of the groundwater in that area. And if the soil moisture is lost due to the departure of the rainfall, negative departure particularly, then besides meteorological drought, agricultural drought automatically comes. And hydrological droughts, because depletion of groundwater is occurring, and just I am one by one, I will be coming to that point, so you will realize that how the groundwater depletion has been estimated over this larger area, and how we can estimate in much more other larger area if you are going to have such type of approach. This is the methodology flowchart where we are taking the satellite data, GRACE, then Terra climate, and then CHOPS. CHOPS is nothing but it is related to the rainfall, and CHOPS stands for Climate Hazards Group Infrared Precipitation. Climate Hazards Group Infrared Precipitation, CHOPS, and it is a larger set of rainfall data, and we have taken that rainfall data for, you can say, the calculation or correlation rather between the water table depletion and rainfall. Then Terra climate data we have taken to estimate the change in just before in the beginning I mentioned that this formula I am just sharing again here. The change in the soil moisture, change in the snow water equivalent, and change in surface water, all these we are estimating with the help of this Terra climate data. So here if you are, I have already spoken about this thickness of CSR, GFZ and JPL, three sources, and it reflects the time series data or time series trend, and how much quantified means the ranges in the change in the storage, and we have taken the mean out of his, and the purpose is all the data are, you can say, rasterized in the raster form by the Google Earth Engine here. GEE stands for Google Earth Engine. So all these data are changed into the raster form so that it can read in the pictorial format. And after that, here ground-based data, spatial distribution of wells, certain wells, already you know that the State Groundwater Department of Central Groundwater Board, both are having the groundwater stations, observation wells are there, hydrograph stations are there. They are monitoring continuous the real groundwater level in the field. So this is for validation. We have taken the chosen the data, taken the data for the validation. How much, up to what extent we are correct, or we are near to the real or realistic features or figure. So here the time series trend, average annual rainfall, average soil moisture we have taken, and then we have put all these things on the platform of Google Earth Engine, and after that we are getting the groundwater by total water, terrestrial water storage minus ESM. ESM here, if you see, it stands for the ESM. Just a moment. It is, I think. Okay, estimated soil moisture. Sorry. So estimated soil moisture, if you deduct out from the terrestrial water storage, then we are going to get the groundwater. Because here the estimated soil moisture is also important for the drought, as I mentioned separately. Because estimated soil moisture is important. Why? Because it is requirement of the crops. So agricultural drought will be highly affected by the soil moisture. So if soil moisture we are estimating, then certainly another fragment or another, you can say, the sector where agricultural drought can be addressed very well. Besides that, if you are detecting this estimated soil moisture from the terrestrial water storage, we are going to get the groundwater, change in the groundwater condition. So if depth to water level, and by IWD, as you are very much aware of this interpolation, IWD, it is a very common practice for contouring, and whatever the point are the non-spatial data, we are plotting on the map, and we are changing into the spatial data set, means the thematic maps, which are reflected in the time and space both. Then certainly we are explaining in better way about the real condition of the groundwater condition or any other features related to the ground surface. Subsurface, we are here explaining subsurface condition related to it is groundwater, but surface conditions certainly we are explaining here the subsurface up to certain extent, root zone, the soil moisture. Then topography, we are dam, we are also having, with the help of all these, we are proceeding towards the Google Earth Engine, and such type of, you can say, the framework appears, or you can say the screen appears, and then we are one by one, we are putting the data sets according to it, and we are getting the such pictures. And from the equivalent groundwater thickness, EGT, you can say, or groundwater thickness Means groundwater thickness means what is the column of the groundwater actually. So groundwater thickness or change in the storage of the groundwater, we are estimating how we are estimating the grace in the Bundelkhand region under case study. Period has been selected from April 2002 to February 2017. Then you can ask why such period has been selected, because on the other hand, we are collecting the data, real data of the groundwater table from the different sources, like I mentioned, the State Groundwater Department as well as the Central Groundwater Department, Ministry of Jal Shakti, so that we can validate. So first, we do the reverse process. Reverse process is that we are finding that as much possible, the larger data sets are available with us, actual data, field monitor data. And then we are taking the satellite image data or satellite data because those are available with us. So therefore, so that in future we do not have the problem regarding the validation. The data contained equivalent groundwater thickness represents the deviation upon the vertical. I have already spoken, or you are knowing it. Main point is here that the findings reveal in Bundelkhand region of Uttar Pradesh that the vast variation has been observed in the different districts in the entire Bundelkhand region. The change in the groundwater thickness varies from 247 millimeter to minus 281 millimeter during April 2002 to February 2017. Means in 2002, the change was 247 on higher side. But here in 2017, it has been seen that it has below zero, it's minus 21 millimeter change in storage. So it reflects the drought condition over the period. The downward trend has been observed. I have already mentioned that which are the peculiar years, or sorry, particular years during the particular period rather, during which this departure or the change in storage in the groundwater has been reduced drastically, and those period or those years belongs to year from 2009 to 2017. A very you can say unique pattern we observe. Just you will visualize through the diagrams or the figures or graph. Then yes, there is a drastic difference from the 2009 to 2017. 2009 से पहले वो चेंजेस नहीं आपको दिखते हैं जो 2009 के बाद दिखते हैं. तो इसलिए there is a lot of changes, and I would like it in my personal opinion, UFO transpiration rate has been increased over this period also due to the change in the temperature. So if you are correlating the temperature change also during this period, and you are reflecting it or correlating with the evapotranspiration, certainly soil moisture will be more, loss of the soil moisture will be more during this period than before. So my point is here, we should also collect the data related to the temperature. We have already the data sets, larger data sets of the rainfall, and then we can throw the light in a better way regarding the soil moisture, change in the soil moisture, or you can say the soil moisture loss, as well as the occurrence and the groundwater and changes in the groundwater storage. On an average, one means mean, maximum, minimum I have already told earlier in this slide, but mean average 112 millimeter decline of the groundwater storage level has been depicted or has been observed rather during 2003 to 2016. Means it is 11.2 centimeter, and 11.2 centimeter change in the groundwater storage level, although the value, if you see, it is less, because if you find in the reports in the newspaper or any journal or anywhere, you find the change in the depletion in the large, this 12 or 13 years, you say that 2 meter decline ho gaya, 3 meter decline ho gaya. Yes, actually point data at the different location you may have might have observed that at certain location there is a drastic departure or the drastic decline, you can say, in the groundwater level, 2 meter, 3 meter in for the last 10 years. Hello. 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 Some participants are discussing certain issues. May I know what is the problem? Hello.
Sir, can we get the Google Earth engine code for the groundwater assessment?
Hello. Is there any problem from the participant side? Because participants are discussing among themselves. So please let us know. Hello.
हेलो हेलो हाँ हाँ सर आप कंटिन्यू करिए आई थिंक कुछ किसी का माइक ऑन हो गया आई विल जस्ट म्यूट देम हेलो पांडे सर
Yeah. I will continue.
हाँ you continue one of the participant I think Kiran wants to ask some question maybe we can take that question Kiran Kumar Mohapatra you can turn on your mic हाँ
Hello, Pranam sir. Sir, can we get the Google Earth engine code for the Grace groundwater assessment?
Yeah.
Sir, how can you get this?
Because you can download the Google Earth Engine as well as Grace data, both they are available, and you can perform the process.
Sir, I need the code only, sir. I have no idea, about Google Earth Engine. Yes, sir.
Yes,
sir.
It actually I will tell you in the after class, because
Yes,
how
sir.
we can download this entire process. Then if let me finish first. I thought that you are
Okay,
putting
sir.
certain questions out of it regarding the code. Certainly,
Yes,
I will
sir.
discuss later on. Okay.
Thank you, sir. Thank you, sir.
Okay. Then the graph. There are two graphs. One is the top one is if you recall back, then the three sources of the data sets we have selected CSR, GFZ, and JPL. So they have been depicted. You find that out of these, either in the tabular form, if I go through the back to this slide, if you see, the variation is very close, or variation is very less, and they are very close to each other, the data set, and that has been here shown in the graphical mode. If you see, the change in the groundwater storage level changes over the period of 2002 to 2017. Then we are finding that all these sources are very close to each other. Means the findings of these different sources are variation is not very huge or very, you can say, large, so that we cannot select and we can take the mean. If the variation is so much large, then we cannot select the mean, because as for the simple mathematics, if the data set is quite variation is large among the data set, we should try to restrict ourselves to take or adopt the mean value. Here, if you see on the top, that the variation is very less out of all the CSR, GFZ, and JPL, then we can select certainly the bottom graph of same things, change in the groundwater storage level. Then we find that in the mean value we have selected, and we have seen this graph. So if you see the pattern, from the 2002 to 2017, you see the depletion. Earlier, before 2009, if you look, as I mentioned, in each year on the higher side is there. But after 2019, you can say decline has been started, although the magnitude is not so, you can say, the intensive or the so much large, but it has started. And the decline trend is more prominent than rising trend. So if in the graphical mode, we have done like this, thickness for each year we have calculated, and using ArcGIS software, we have just brought all these things in the spatial mode. And if you look towards the thickness, high, medium, and low, then you find that the thickness higher means it is average groundwater thickness. If higher, it means it is supporting the, you can say, it is a good condition. If it is medium, it is a lower condition. And it is low, it means the worst condition. So if we see the 2002, 2003, 2004, 5, all these, then we find that the after, I think, is, if you see here, the entire, during 2007, the most of this north eastern part of the Bundelkhand region has gone under the low groundwater thickness condition. The reason is very valid, that if you take the rainfall during this period 2006 and 2007, the drastic decline in the rainfall has been recorded. So besides the rainfall, another factors is also there regarding the withdrawal, because withdrawal has increased many folds over the periods due to the rapid increment in the intensive agriculture, or you can say the industrialization, or even the population growth, urbanization. All these factors are responsible for the withdrawal of the groundwater. But even our aim is to see what is the trend in the change in the groundwater storage over the larger area of this study. How we can analyze, how we can correlate, connect it rather to the drought analysis. As I mentioned many times, I repeat again that there are many types of the droughts studied. It has been discussed in detail. And hydrological and agriculture droughts, they are directly related to the depletion of the groundwater table, because soil moisture loss will be much more if the water table is declining over the period. Then if you see the changes here, this area here, northern part, this area are becoming very common during this 2010, means after 2009, as I mentioned. This area, the common pattern we are observing here, that the low groundwater thickness is being observed in this part, and then followed by this medium here, and then here higher. Again, if you see this condition from 2014 to 2017, again the similar pattern. So my point is, after 2009, we have seen that, you can say, the area which are northern part has been experiencing a Bundelkhand region towards much more drought condition than the other parts. So regarding the relief and the future strategy can be based very well on the findings of such a study by the district administration or the peoples involved regarding the relief or management of the drought condition. Because as you refer the topic of the short-term course, drought analysis and their management. So until unless we perform the analysis, either in the at the society level, human level, or technical level, or using your academic skill, we cannot manage any natural disasters in an efficient manner and in a timely manner. Because time is very important to manage any drought or flood impacts on the society. If you are managing or you are evolving the process which are time consuming, then certainly those processes or methodology for mitigation of the impact of the drought or floods will not be appreciated by the society. So as soon as possible, as much as possible, if we try to attempt by putting this technology or using the different applications of the software which I am just discussing, or the platform like Google Earth Engine, or the application of the GRACE data on the larger scale, and then certainly group can work and we can validate on the ground where such situation is there or not. And then certainly we can go ahead on the more larger scale, and we can recommend that this area requires the first priority, means the attention first attention or priority on the priority, the management of the drought should be there. Here I am focusing on the drought, and I am really connecting, I am trying to connect the depletion of the groundwater with the drought analysis. Then the soil moisture, terra climate, I have just already average soil moisture estimation. So we have seen during 2010 and 11 the drastic reduction in the soil moisture, and again it is due to the related to the rainfall. And 2005 to 2006, between 2005 to 2006, 2007, 8, and 2009 and 10 and 11, these periods have experienced the loss of the soil moisture than other years on an average. So one factor here and one thought prevails among us or with us. Still, here is one question I feel personally, that if we are correlating with the rainfall and soil moisture, and other periods, other years, the rainfall is also declining, and or you can say it is near to the mean, why soil moisture loss has not been the such way as between 2005-6, 2010-11, and 2007 and 8. The point is that besides this rainfall, how much you can say the irrigation is made also by the utilization of the groundwater or withdrawal, because if withdrawal increases from the groundwater during any particular year, and if the rainfall even it is surplus, or if it is you can say the optimum, the soil moisture loss is depicted. Because if you are enhancing the groundwater withdrawal, certainly it will reduce the soil moisture after a certain period of time, not immediately, but after a certain period of time. So because retaining power or retaining power of the surface soil regarding of the precipitation up to certain, because the surface receives the temperature also by the sun temperature, sunlight. So if the evapotranspirational loss is significant, and if it is entire over the period, but during certain period, if the groundwater withdrawal is increased for the agriculture or irrigation, for intensive agriculture, or the drastic reduction in the rainfall. So out of any of these factors, the soil moisture can be affected. Here, the average soil moisture map has been prepared in millimeter, the unit is in millimeter, and you see the southern part of the soil moisture area. If you look towards this, the average groundwater thickness and soil moisture. After here again, if you look towards the soil moisture condition, it is minimum in southern area here, and it is very common in all the years. The southern area is having the minimum soil moisture condition and maximum in this area. So one thing is that the soil moisture, if you look the entire from 2002 to 2017, in most of the year, exceptionally 1 or 2 here, entire the southern part patch is having the, you can say, the minimum soil moisture condition. So if regarding the agricultural drought condition, we are trying to classify, then certainly the southern part of the Bundelkhand region, particularly Jhansi and Mahoba, they are suffering a lot from the soil moisture, and it is related to the agricultural drought condition. While if you hydrological drought condition, if you look, then it refers to the northern part of the Bundelkhand region, and then followed by the eastern part. So northern and eastern part, they are providing and throwing the light that hydrological drought conditions are prevailing more in the northern and eastern part of the Bundelkhand region, while the agricultural drought, because agricultural drought is directly related to the soil moisture first and then hydrological condition, then it is related to the southern part of the Bundelkhand region. So regarding the management options, after these analysis, we can say that the surface water conservation measures may be attempted in the southern part of the Bundelkhand region on priority, and while the subsurface water conservation practices, there are a number of the methods of the subsurface and surface, like contour bunding, then trenching, then you can say gully plugs. All these are related to the surface conditions, surface water conservation measures, while if you are constructing the subsurface in this dike, subsurface dam, subsurface recharge shaft, recharge well, all these are pertaining to the subsurface water conservation measures. So regarding to tackle the hydrological drought condition, because it is related to the groundwater condition, change in the groundwater thickness, so we should try to attempt subsurface if possible, because other conditions also governs about the implementation of these schemes, these projects or these techniques. Not only the groundwater table condition only, other condition. How is the topography? What is the soil condition? What is the, you can say, the rainfall? So all these conditions also are there, but in majority, the northern part of the Bundelkhand region is providing us the area or providing us the, you can say, the domain where we can attempt or we should go for the subsurface water conservation measures to tackle the drought, hydrological drought condition. While if you are coming towards the southern part or of the basis of the soil moisture condition, then certainly southern part of the Bundelkhand region require the surface water conservation measures more than the subsurface. So it is one aspect. Then the net groundwater storage, equivalent water thickness, we are getting that from the base EWT minus soil moisture, which we have calculated just now. We are going to get the net groundwater storage. If you see the net equivalent water thickness, how over the period minus soil moisture, it is showing the drastic decline. If you see in the minus, if you see in the net equivalent water thickness, it is starting the departure over the periods. If you are declining faster as well as continuous decline, it means it proves that there is a clear cut hydrological drought condition which can impact or which has impact on the agricultural drought condition or agricultural drought. So both droughts are prevailing or have been prevailing either in the lower magnitude maybe, but it is prevailing. So we should try to see most of the funds, or we are receiving lot of funds to tackle the water issues, either surface or groundwater in the entire Bundelkhand region. Focus is very much either from the state government or the central government. But as far as technological input and output, number one. Number two, our research, you can say findings or the thoughts, we should see that what is the quantum or magnitude of the decline, how much we should worry, in which area we should, which area should be prioritized on the availability of the fund, on the availability of the money, so that the wastage of the money without observing the, you can say, the area specific under the different route, we should try to avoid or restrict the water conservation measure or the mode or methods which are involved under the water conservation measures to drought proof or proofing of the drought. So drought proofing requires this analysis on the larger scale. As you know that satellite image, you might have aware that it is not new things which I am just telling with you people, but just try to stimulate and myself also as well as you people motivate, show that more knowledge you are having and you can share your input in the other area and analyze the drought condition and magnitude, intensity as well as the type or nature of the drought. If you conclude with these, certainly your second duty or our second duty is what is the solution. Solution refers to many, but certainly if you have prioritized the area, first our attention, proper attention should be towards that area, number one. Now if you move to that area, you first validate your findings with the real groundwater situation or real groundwater condition, soil moisture condition, crop condition, and then you recommend that such type of, you can say, measures related to the water conservation in particular district in the entire Bundelkhand region or part of the district we should provide or recommend. Because seeing is believing, I should not tell much, but I have experienced lot of experience in the certain districts of the Bundelkhand. So one thing I can tell you that all the districts are suffering or facing the problem of shortage of water during the summer season. But if you see the entire geographical area of any districts, in totality they are not suffering, because in certain pockets they are having the water, either surface water or groundwater, but in certain pockets certainly there is acute shortage. So again, my point is, after again and again I repeat these things, validation is very important. We cannot jump just only on these findings that yes, now entire district is suffering from acute shortage or acute decline of the entire, but at the larger scale, certainly we can say that scenario is that it is not, you can say, the healthy scenario. You are not, you can say that it is not the good scenario. It is a you can say deteriorating stage related to the hydrological conditions or the availability of the soil moisture as well as the groundwater storage in the entire Bundelkhand region. So the next is bivariate relationship. As I mentioned in the beginning, that we are having the large set of rainfall data also in the millimeter, and the groundwater storage level change on top, precipitation is there, on the bottom groundwater storage level change has been depicted. So if the values only during certain years it is crossing the zero in the positive, and most of the values are falling or pertaining to the negative, means related to the groundwater storage level change. On the, you can say, if you see the precipitation and the values in millimeter, so the recording to the precipitations and precipitation, if it is higher also, but the change in the storage restrict to the maximum minus 250 millimeter, means the negative departure of the soil moisture, this groundwater storage level change. While if you see the precipitation, it is in the maximum cases, it is negative departure, but it is 500, means the on an average it has been precipitated, because in certain years the average rainfall has reached up to 1050, 1150, 1100 also. But most of the, if you are taking the data and you are calculating on an average, then certainly it is beyond, it is more than 250 or 300, 400, and it is going to the 500 millimeter. But I cannot say कि हर साल बरसात केवल 500 mm होती है बुंदेलखंड में, ऐसा नहीं है. If you see on an average it has been made in the larger area. So my point again says that this study, such type of approach is suitable for the larger area, versatile program versatile approach. But if you want to validate at a micro level, certainly you have to have the real groundwater table data, as well as if you are having the larger number of the rain gauge stations data pertaining to each district, then certainly you can have the more accuracy. Then the average annual rainfall data here, if you see, I have already mentioned, you will find the difference. It is not 500, but in certain years it has reached even beyond 1000. And but low rainfall, larger set of data has also revealed this part, Jalor, and extreme western part, northwestern part of Jalor and Jhansi. So here is the, you can say, the change in the groundwater level during the monsoon and pre-monsoon. It is a real data. It is a real data which we have collected from the State Groundwater Department as well as Central Groundwater Board, and these data have been taken into consideration for validation. And after that, we are finding that the deeper water table here in the northern part, as I mentioned earlier also, that the change in the groundwater storage level from the grace is restricted to the northern part. Okay, so this is the groundwater table data, and the deeper groundwater table is restricted, or you can say confined towards the northern part. And this is the pre-monsoon 2015, then August, then post-monsoon means during pre-monsoon, during monsoon, during post-monsoon, and the last is the groundwater level post-monsoon 2017. So in entire, if you are observing that it is reflecting that the deeper water table is restricted or confined towards the northern part, which is corroborated by the findings of the GRACE. And here, if you are finding that this area, I have mentioned the low groundwater thickness, so it is being validated. So with these words, I finished my talk. I thank all the participants for their patience hearing or listening. And if you have any doubt, you can suggest me any confusion, any doubt, and I certainly heartily welcome your suggestions, because it is not ultimate. My presentation or my findings is not ultimate. It is one approach which I have discussed and we have used in our one of the research article or paper which we have carried out in the Bundelkhand region. So with this, I stop myself here. Thank you very much.
Thank you so much, Pandey sir, for such an insightful lecture. Any questions from participant side? Any participants wants to ask something to sir?
The soil moisture data in CRIPS, how much accuracy it is?
Pardon?
The CRIPS data from the soil moisture from the satellite image, how much accurate it is after validation?
After validation, it is 85 to 90%. In the beginning, I said that if you are getting the 90% or 85% accuracy, I was satisfied, because in the larger area this attempt has been made, and more larger area you can attempt. Beyond this also you can attempt. It is up to you. And one approach we have attempted, but as far as accuracy, you have rightly pointed out that experimental setups which are estimating the soil moisture in the field conditions, certainly we cannot achieve with the application of the GRACE.
That reference we can use for further study?
Yeah.
Or every time validation is required? Because
evapotranspiration and other soil moisture measurement is also performed by the experimental methods which are carried out in the field also. You might have been knowing that there are many methods, yes, many instruments which are applied in the field condition, and we are getting the soil moisture, and then we are getting the water balance study regarding the drought analysis. In the drought analysis, yes, if you see the manual of the NIDM also, you find, and many literatures, that many experimental, yes, methods have been, but it is one of the attempt I have discussed with you people. And I mentioned many times that don't take it a guarantee that you will achieve the 100% accuracy. So I tell you that 85 to 90% accuracy if you achieve, because ultimately the impact of the soil moisture and the change in the groundwater storage has been validated by this real groundwater monitoring level data from the Central Groundwater Board as well as the state groundwater departments. They are monitoring 4 times in a year.
Thank you.
Okay, any more questions from participants? You're free to ask any questions on any level that you want to ask, starting from basic to advanced. Sir has vast experience in the groundwater field, so you can be free to ask any questions.
Any suggestions from any participants regarding the, so that we can also provide certain more input, although we are have faculty in our department also, they are having a lot of experience, but since this is a very good opportunity here at this platform, because time is over now, so I request any of the participants who have worked or is working in this area, you can suggest us also that what should be the point to be incorporated so that we can get better accuracy and our approach can be modified in a better way. It is not the you are participant, but we welcome your idea at any time in any deliberations, so that we value you very much.
Okay, so any questions?
I
Yes,
request, and I think Dr. Pramodji already have spoken to you that I need more participation, because I request all the participants to propagate among the registered participants on the WhatsApp group you are having, that they should enjoy other lectures. The next lectures is very interesting, and you will be very happy. And let me finish now. I stop here. Thank you, Pramod. Thank you.
No, sir, you can take your time. Complete. It's no problem.
No, I have already taken my time. It is 11 o'clock and 11:03 rather, 11:02. So I do not want to encroach, but certainly the participants, if they are having any doubt, any question, I welcome.
We are waiting for the next speaker, so we still have time. So sir is trying to connect, so we can have discussion if they want. The participants, if they want to ask, can ask. And still, if you have any queries after the session is over or after the course is over, you can always connect us with email.
I hope all the participants you are receiving from the Dr. Pramod sir is providing you the PPT and other materials very quickly at your request or demand, I can say. So I hope you are satisfied with the material which study has been provided to you all. But my request on the other hand is that you please attend, enjoy, because already you have registered yourself in the course. So holidays are also there. You enjoy the lectures, because other lectures are going to be more important. They are very well experienced and they are working energetic. They are energetic working in this area than us. So practical sessions in the next afternoon. It is very interesting. Although
Mahi Yadav, yes. Mahi Yadav, you can ask a question. I think you raised the hand. Yes. Okay, maybe it was by mistake.
Mahi has raised the hand and left.
Maybe no, she's there, but I think maybe it was by mistake. So, anyways, so I think Dr. Himanshu Arora so he's trying to connect. Actually, because of some proxy issues, he's not able to connect with us right now. So I'm trying to contact him so that he'll connect soon.
Okay, if Pramod problem persists, then I can request Surya Prakash to take over. अगर problem persist करती है तो, otherwise.
Okay, I'll contact him on phone and I'll confirm if it's taking time, because
by that time I am discussing among the participants. You try to connect with.
I'll call him and see. If
okay.
Sir.
Yeah.
Sir, can I ask one question, sir?
Yeah.
Sir, is there any condition like minimum area should we have for this modeling?
Very good question. As I mentioned in the beginning, that 300 to 400 kilometer minimum square kilometer area minimum.
Okay.
Okay, required, because its resolution is up to that level. Grace data availability is there on on this scale. So if you are selecting 50 square kilometer, 100 square kilometer, or even 1000 square kilometer, it will not so much have the it is not worth to attempt. But if it is a larger area is there, then certainly you will enjoy.
Okay, sir. Thank you, sir.
Any problem to participants? Any problem? Other problem related to this subject? This topic? Because we are coordinator
Pandit,
here. Yeah.
I
Yeah.
talked with Dr. Himanshu Arora. I think he's trying to connect. It may take a couple of more minutes.
Okay.
If Dr. Surya Prakash sir is ready, so we can start his lecture and we
Yeah,
can
yeah,
take.
yeah, yeah. I confirm. Just I confirm with
Yes,
him
sir, you
because
also. If he's ready, then we can continue with that lecture, and Dr. Himanshu's lecture can be taken up later on.
हूँ, you can explain it. ठीक है, connect करो. So regarding the just we are waiting for the another speaker. Within a moment he will join. But by that time, one of the participant has asked regarding the code. Who was there in this code of the Google Earth engine? One of the participant, I think he has
Yes,
left.
sir. Yes, sir.
Yeah, Kiran Kumar.
Yes,
Kiran Kumar, you had
sir.
asked the question related to code because I told
Yes,
you
sir.
that in the beginning that this presentation is based on our research findings, or you can say the manuscript which we had been submitted to the one of the reputed journal. So my research
Yes, sir.
scholar, Mr. Vishal, he is also one of the participants in this course. I have already asked him to explain about this. So he will explain, just please listen. Okay?
Yes, yes,
Regarding the coding, okay?
yes,
Of
sir.
the Google
Thank you.
Earth engine. I think you have asked this question. I hope Dr. Sudhir Kumar Singh has joined.
Yes, sir. Sir, I am audible.
Sir, आप हैं?
हाँ sir, I am audible to
Oh,
all.
very good. Very good.
Very good.
Okay. So, very good afternoon to all of you. Am I audible to all of you?
Yes, sir.
Very good. So, before I start the second session after lunch, means the first session rather after lunch, hands-on ArcGIS, and as per schedule, Dr. Sudhir Kumar Singh and myself will be associated with this program or this, you can say, the session. And before I start or I invite Dr. Sudhir Kumar Singh ji, let me briefly introduce about Dr. Sudhir Kumar Singh. Dr. Sudhir Kumar Singh is Assistant Professor, K. Banerjee Center of Atmospheric and Ocean Studies, Nehru Science Center, University of Allahabad, Prayagraj. He is my colleague, as well as we have long association in connection with the research as well as the project implementations at different stages in the different area. And Dr. Sudhir Kumar Singh has a very vast experience as far as research in the area of application of remote sensing and GIS related to the evaluation of the, you can say, the groundwater, surface water modeling, land cover, its impact, means the vast area of applications he has, and he has a very good number of publications. If you write his name, you will find yourself the citations as well as the H index, whatever the today's, you can say, the scale for the measurement of the competency in the academics. So you will find. So I will not consume much more time, but certainly I firmly believe that his deliberations or his demonstrations will certainly enlighten you, and you will feel that whatever I have given a brief introduction about him, you will find much more beyond that. So I request on behalf of organizing committee, I request Dr. Sudhir Kumar Singh ji, please join with us and start the session.
Thank you very much, sir, for inviting me to hands-on training. So, sponsored by NIDM, National Institute of Disaster Management. And like you people are continuously listening the lecture. And see the lectures related to the GIS and how and what type of disaster India is facing. And so I am audible to all of you because maybe I am not visible due to I am using the desktop version of my system. If you find any
थोड़ी सी प्रॉब्लम आ रही है सर, थोड़ी सी आवाज की प्रॉब्लम आ रही है.
अच्छा, आवाज सर ब्रेक डाउन हो रहा है क्या?
Now it is okay. Now it is okay, sir.
आवाज ब्रेक डाउन सर. हेलो.
हाँ सर.
अब सर आ रही है क्लियर? आई थिंक आप क्लियर.
हाँ अभी आ रही है सर.
हाँ, क्योंकि मैं ऑफिस लैन यूज कर रहा था ऑफिस का, तो नाउ आई एम यूजिंग द मोबाइल डेटा. राइट. हेलो.
हाँ सर.
सर अब आ रही है भाई?
हाँ बिल्कुल बिल्कुल क्लियर है.
अच्छा ठीक है. So basically the topic was assigned to me was ArcGIS and the ArcGIS and how we are going to use the ArcGIS for our water resource management in terms of like to read the sustainable development goal postulated by the United Nations. In that context, we find that water is very important. The raw the COVID and in the changing climate also. So how and what type of water, global water data is available, easily available, and that data you can directly download and you can use that data for your research purpose for your just like presentation, and it the help of ArcGIS, I can show you one exercise. And first, I will demonstrate you the global surface data explorer. Okay, where you will find the surface data, not the groundwater data, surface data, and from there we will download the data, and then I will demonstrate you how, what kind of basically the data is having, what kind of features or what kind of parameters the data is having, and how. Okay, so that is our first exercise. Second exercise, we will go through the basically use of 3D analysis, and we can just estimate how we can just visualize how this flood is basically presented. We have a there because we have limited time, otherwise we can go for some other exercise like real time flood. Okay, so we will just cover that second topic, and third topic, or simply we can say most of the people are letting know the basic functions or what basic functionalities of ArcGIS. Correct? That is a commercial software, and same you can also find in the QGIS, that is open source. Whatever the software you are using, that is up to you. But the data will, which I am going to share or which I am going to show you, that is you can easily download and you can usually use in the your software. Correct? So these three basically 2 or 3 exercises somehow we will cover in the given time period. If you will find any like problem or uh, any comment or you want any suggestion, so then you can stop me during my presentation also. Okay. So as I was like informed that most of the people are having different background. Like from this group is having diversified disciplines. So in that context, I assume that you all aware with the ArcGIS and the basic functionality. But I will show you. I will demonstrate you. So, sir, I will share my slides, or you can just allow me so that I can share my slides, sir.
Yeah, शेयर कर सकते हैं डॉक्टर साहब.
But sir, only it shows that only meeting organizer and presenter can share it.
Okay. Let me ask Pramod to आपको presenter बना दें. First,
Yes.
just a moment, sir. Just a moment. Dr. Pramod. Okay. Thank you. So, sir, now you are as a presenter, you can now share your slide.
Yes, sir. Actually, I don't have slide. Directly I will demonstrate.
Okay.
So before I am going to start this presentation, so first I will let you know that I started with the ArcView 3.2 version, and now I am using ArcGIS 10.4, and now you will find that people are using the ArcGIS Pro. So ArcGIS Pro is much difficult to find here as compared to, and there are lots of data. We have developed lots of data and directly download or you can directly count that data into that paper. ArcGIS. So I will demonstrate you my exercise on ArcGIS 10.4. So just So I just like want to know how many of you are simply in majority. How many of you are in majority? How many people have already used the RGS software?
Dear participants, please respond. Sir is
Okay.
asking how many people or how many participants are aware with the basic idea or basic hands-on the ArcGIS. You are acquainted with the ArcGIS? Yes. One body has many are there, I think.
Okay.
Still, yeah.
So in majority, I can understand that majority of people have already go or they
Yeah.
have used their study. They have used their study. So this is the basically RGS. Yeah.
सॉरी वो आपके बैकग्राउंड में कहीं से नॉइज आ रही है बिकॉज पार्टिसिपेंट्स आर राइटिंग कहीं से बैकग्राउंड में नॉइज आ रही है क्या आपके आसपास
Sir, background noise. I think as a background noise, sir. Now it is fine, sir.
हाँ इट इज फाइन थोड़ा सा तेज बोलेंगे तो अच्छा रहेगा
जी. Okay, sir. Okay. So first I will just show you the global water explorer actually. The global surface water explorer. The surface water actually in this website you will find that surface global surface water actually global surface water database. So here you will, if you read this sustainable development goal 6.6.1, okay, so you here it is showing that the European Commission, you just forget that the main goal of this sustainable development is that the water, okay. So how we will use this data, or we will use this data in our ArcGIS, correct? So my objective is first I will just do the briefs like what is the global database available for different purposes. Whether you are going for your basically integrated water resource management, correct, or wetland monitoring, or you whatever the basically you write the cases, you can just you can use that data. So
डॉक्टर साहब आप कुछ
like
शेयर कर रहे हैं या नहीं शेयर नहीं हो रहा है ना अभी कुछ
सर शेयर नहीं हो रहा है सर
ना
तो एक मिनट सर अच्छा सर जस्ट मिनट मैंने सर शेयर तो नो शेयर ट्राई अगेन वेट मिनट
एरो हो एरो आपके पास
हाँ सर एरो इज कमिंग सर अपवर्ड एंड डाउनवर्ड
या
सर ये नाउ इट इज फाइन सर शेयरिंग हो रहा है सर
नाउ अभी तक तो आया नहीं है
सर आई थिंक शेयरिंग हो रहा होगा
dear participant yeah now it is clear
now it is clear okay so I was just giving the information that this global surface water explorer, correct, global surface water explorer, you can directly just google it, the global surface water explorer. You will find that on this website actually there is a basically you will find that explore. If you click on explore, then you will find that there is a data about basically this data is available from time period of 1984 to 2019 in the GIS framework, and if you like 20, up to 2020 it is in the Google Earth Engine platform, correct. So from last 36 years data is available at this website, global data is available, and this data is basically derived from the satellite of satellite Landsat satellite 5, 7 and 8, and its resolution is 30 meters, okay. And what is the basically need of this data? If you read the article written by the authors, whose article was published in the Nature. So what is the need? Why basically people are using this data, or why these scientists have developed this data for betterment of the people? Okay. So what the objective was, where and how often did surface water occur between 1984 up to this period? The satellite, when the satellite remote sensing satellite was launched, from that period to up to this period. Okay. And what is the percentage of occurrence? What is the percentage of non-occurrence of the water? What is the occurrence change? Correct. How the intensity of water is going to be changed over the period of time. If you just study the 1984 to 1984 up to 1995, or you can just take the two different frameworks like two different time period framework up to 2014 to 2019. So you can easily compute the intensity, how intensity is basically changing from this data only. We are going to use this data for our first exercise. Okay. Then water seasonality, that is also very important component, like whether the water is a permanent means throughout the year, the water remains throughout the year in your ponds, lakes, or your river systems, correct, or your reservoir. Then there is a seasonal, like whether the water is seasonal up to how many means up to what time the water can remains in the water body or reservoirs. Okay, so then you will go for the annual water reoccurrence, means how often the water was an the area was basically how often the area was flooded by water from one year to another year. Okay, so that is also very important. We have to understand like annual water reoccurrence.
आपका
So
स्लाइड डॉक्टर सर या
सर
एक
इसमें
स्लाइड है
slide- सर इसमें स्लाइड नहीं है बेसिकली दिस जो इस पे द डेटा, ओके, जो डेटा अवेलेबल है सर उसके बारे में मैं
ओके
पहले बता रहा हूँ और यहीं से फिर हम डेटा एक डाउनलोड कर
ओके
लेंगे सर, है ना सर?
ओके
तो
प्लीज
ये
पार्टिसिपेंट जो है बार
जी
बार ये लिख रहे हैं
जी जी
कि स्लाइड मूव नहीं कर रही है
अच्छा अच्छा सर एक्चुअली
पार्टिसिपेंट
मैंने
शुड बी
जी
इनको
सर
मैं बताना चाहता हूं कि अभी स्लाइड मूव करने का नहीं है, अभी सर जो डिस्कस कर रहे हैं कॉन्सेप्ट और उसके बाद डाटा सेट पे आएंगे।
हाँ हाँ उसके बाद सर लाइव डेटा हम लोग डाउनलोड करेंगे एक और उसके
बिल्कुल।
बाद उसमें से हम लोग उसको देखेंगे चीजें चेंज करके, है ना सर?
I hope participants have listened the remarks of the speaker, so
हाँ
please be attentive and listen.
बिकॉज ये सर बहुत अच्छी वेबसाइट है, दिस वेबसाइट इज वेरी इंपॉर्टेंट और
Very
you can use for your like project or dissertation work. Okay, so that's why I'm telling this. Like you will find there water occurrence data, then you will find water occurrence change intensity data, then you will find water seasonality. What we are going to, we have already discussed that up to 3 points we have already discussed. Then you will find the annual water reoccurrence, like how much area was flooded. Okay, by water from one year to another year. That is also very like if you study the Prayagraj and you will see that how many years the water was flooded and how many years the water was not flooded from some your reference points. Then you have a water transition. Very important. Basically, this data set is very important. Like what is the change between the first and last year? Okay, and what is the basically you will find that what is the we have already discussed like seasonal water, permanent water. Okay, maximum water extent up to like in last 36 years how much water has been the area has been flooded from last 36 years, whether it is flooded or it is residing from some areas, like so you can just use this maximum water extent. Also water history, that is very important. Like water history means what is the basically monthly and annual frequency of water coverage at each location, so that will tell you the water history of that particular area. Then what is the applicability of this data? The applicability, I have already told you that monitoring of reservoirs you can easily do, the monitoring of wetlands you can see, and you can also link it with your climate change. Like climate change means climate change, your climate change basically the concept deals with the data consecutive 30 years, minimum 30 years data should be your correlated. You should correlate with your water data, like temperature, how temperature is changing and how your water level or your extent is basically reducing or expanding. So you can just uh, because the data, as I would told you, the data period from 1984 to 2019 in the RGIS framework, and up to 2020 you will find Google Earth Engine platform also 1984 to 2020. So you can just correlate like temperature, what is the impact of temperature, what is the impact of rainfall on uh, your water body, correct? So in this as I told you that here it is written this, if you explore this data you will find home, about, explorer, and then data, articles, the articles, important articles. You will, if you read this one, so you will find that this nature article, based upon this nature the data has been, scientist has been developed this data. So very important basically this article. Before using this data, I suggest you should read, basically you should read and consult this article, so you can easily understand the basically need of this data. Then you have a sustainable development goal I have already briefly touched about this. So we will go like start exploring. Here you will find out all about the global surface water. This was basically a joint venture of European Union agency and your global surface water data set. This, they have developed this product. So find out all about the global surface water. Here you will find explore article data frequently asked question. Frequently asked question is very important. Then you can read like what is the here you will find what do the map shows, why is the surface water important, what does what basically data were used to build the maps, how are landscape data used to map water, what is the surface water occurrence, what is the surface water occurrence change intensity. I have already told you that you can divide your period into different time frames, and then you check like 1984 to 2019, 2002, 2015, and whatever the window you want. Then you have a surface water seasonality, surface water seasonality. Then you have a water reoccurrence. These classes are there. Then I have already told you water transitions. What are the important temporal profile? Temporal profile you can directly get on that one. How accurately was open water on Earth surface mapped? Okay, that is also very important. Like when you use these data, so people will ask, like what is the accuracy of this one? So accuracy of this one we will discuss. Okay, and how reliable are the metrics? Occurrence, reoccurrence, and seasonality. So when you write any article, so based on this data, you can consult this frequently asked question, and many doubts will be clear. So we have this. Then we go for the what is new update interactive discover time lapse. So here and open. That is also important. Yes. Hello. I am audible to you?
वायस बैक पता नहीं कहाँ से बीच बीच में कभी कभी काफी नॉइज आ जा रहा है।
नॉइज आ जा रही सर।
हाँ नॉइज ग्राउंड से कभी कभी नॉइज आ रही है।
तो ये हेलो हेलो
हाँ हाँ
सर अभी ठीक है सर।
हाँ आवाज ठीक है थोड़ा सा कमजोर है।
क्या वॉइस में तेज बोल रहे हैं?
हाँ थोड़ा सा
तेज
अपना
तेज तेज।
हाँ नाउ इट इज ओके।
अच्छे से तो कोई दिक्कत है नहीं। ठीक सर मैं तेज बोलूंगा सर को। ओके सर।
नहीं इट इज फाइन। अभी जो आप बोल रहे हैं इसी तरह ये अच्छा
अभी
है।
ठीक है।
हाँ
इट इज फाइन। Yeah, so here you will see that you need to go back in time to accurately measure changes in surface water. Here there are some case studies. They are showing that disappearing RLC very good example. You can see the impact of climate change here. The lake expansion in the Tibetan Plateau, how the lake is expanding. So based upon that, you can use that. You can go for the some landslide kind of activity. You can just I cannot directly say that you can just forecast or something like predict, but you can just somehow link that one. Okay, and new dam. What is the impact of dam? Basically, large scale dam. If you build large scale dam, then what is the impact on their local environment or microclimate of that region? Is appearing the lake in Iraq actually in Middle East. So these are some case studies people have used. They have applied this data for the case studies. So get them. Our data is free. They are saying that our data is free. So we are going to use the freely available data. License all data here is produced by Copernicus program. That is from European State Agency, and free of charge. Here you will go for the, if somebody wants to legal, then they can give you. Citation, this, as I already told you, you have to cite when you use this data, you have to cite this article. Okay. Data user guide, this is important. You just download and read this before using this data. So background map, products, everything is there. Read, everything is there, and they have also, there is a pop-up window. When you use the data, that time they use some values. You have to understand the meaning, and there is a color coding pattern. Color coding pattern is there. So you use this. Global Surface Water Explorer. Okay. So this is your individual file is available up to this 10 degree cross 10 degree files are available, and the data is set in the TIFF file. There are some other below you will find that the full global surface water data sets can be downloaded using Python. So for interested, they can use this active file fast transfer protocol. From that you can also download. And this is also very interesting. You see the symbology actually. If you are using this data UGS, so you can use the symbology of occurrence. This okay. If you are using the RGS, then you use this occurrence if layer. So you will get the symbology, whatever the symbology they have mentioned in the data user guide for your easy interpretation. Correct? So here we are going to discuss, we are going to use some data. You all people will basically Google the global surface water data, and then you come on this slide actually. Okay, and you download the data for your region of interest, whatever your region of interest, whether it is near Bay of Bengal or it is central India or southern part of India or southern part of India or western part. You just download the data, then you can easily understand like this. Okay. So here when you click, you left click, when you left click, then you will get that granule with top left corner of your 80 and 30 degree north. Top left, correct? Top left. This one. Got my point? So this one is here. These are the data types, whatever we have discussed, like occurrence, change, reality, occurrence, transitions. Transitions means water transition. Okay, like what is the change between first and last year of data in the whatever your classes, like 3 classes of like not water, minimum extent. So we are just going to click on this first occurrence. The file is around like 79 MB. It will take around like, depending upon your internet speed, but it will take around like.
सर आपकी वॉइस बीच बीच में काफी लैग कर रही है सर.
सर लैग कर रही सर, मैं तो इंटरनेट मोबाइल से यूज कर रहा हूँ सर. यार विक्रम, क्या ऐसा हो जा रहा है कि
पता नहीं कुछ रीजन है, क्योंकि बीच बीच में काफी अच्छी हो जा रही है, बीच बीच में लैग करने लगे
वॉइस. सर मैं बाहर निकाला है ना. सर अभी भी क्या बीच बीच में लैग कर जा रही है सर?
नहीं, अभी तो ठीक है, अभी कुछ देर तक ठीक चल रही, बीच में पता नहीं क्या कारण है.
पता नहीं, मैं तो जियो वाले से ही कनेक्ट कर लिया अपना, वहां से हटा दिया सर मैंने.
होता है ये डिजास्टर ऑफ टेक्नोलॉजी.
हाँ. तो सर आई होप मतलब जो है you all have downloaded one file, correct? Because in live hands-on training, I was present there, so that time I can observe like how many of you have downloaded and how many of you have not downloaded. So up to this point, everything is clear up to this point. At least some can respond actually, so I can understand that point everything is clear.
Yes, sir.
So you have downloaded one file, at least one file.
Yes, sir.
So just open your ArcGIS. So there are two methods for recalling or adding your data. One is directly you can add data from this point, correct? The second is, can anyone tell me what is the second option to recall or to add the data? Second point is from catalog also. Then add your data through catalog, our catalog. To add the data through our catalog, you can get the whole history. They are like so. Just so my this exercise is visible to all of you. But ArcGIS, I am performing one exercise in ArcGIS. Hello. हेलो
बोलिए सर।
सर मैं ये पूछ रहा हूँ कि जो मैं ArcGIS में कर रहा हूँ वो विजिबल हो रहा है सर?
ArcGIS तो अभी हो रहा है, अभी तो ग्लोबल सरफेस वाटर एक्सप्लोरर का ही ये जो ग्लोबल ग्रिडिंग है ना, ग्रिडिंग,
अच्छा
ग्रिडेड जो ग्लोबल मैप है वही दिख रहा है इसमें, और जो वो स्लाइड दिख रही है।
ठीक है सर, कोई बात नहीं। तो पहले मैं इसको डिस्कनेक्ट करके फिर उसको कनेक्ट कर लूंगा।
जी जी
चल रहा है। So I will suggest you download all the layers actually. So of a particular area is having 10 cross 10 degree file. So occurrence maximum extent. First we will download this one, and second file you can download, like if you are using the ArcGIS. So like for occurrence, I can download the symbology file. I will download. Fine. If you are using the occurrence change intensity, then you can also go and transitions you can download. So I am just downloading for my exercise. I am just downloading the occurrence tip layer for symbology purpose. I have downloaded this one. Then you will go in the below. You will find all the information related with metadata, like what the protocols they have used. Then Google Earth Engine is available, like tutorial for Google Earth Engine is available here. All these things. So if you find any difficulty for downloading or for any query related with data which is not given in your frequently asked question, you can directly contact them and answer you. Now I have downloaded two files. One file is for one file is occurrence, okay, and second I have downloaded one for ArcGIS. I have downloaded the symbology layer, means occurrence dot tip dot layer for symbology purpose. Okay. Here you will get direct. Later I will demonstrate you the how to add the data on your ArcGIS platform, and then so here there are some in the right hand side, like it is written, click anywhere on the map, obtain temporal profile chart for that location. Just we are taking and can zoom, or like just we are taking some. Here you can also search in terms of, like we are going Tehri Dam example, or any dam you can go for, like okay, or your signal. There you can directly search here. So if you are clicking on, then then you will find that loading temporal profile, correct? So it is showing that valid observation water reoccurrence. Got my point? Valid observation and water reoccurrence. So reoccurrence, water reoccurrence means how often was an area flooded by water from one year to another year. Correct. So the data is available. It is showing from 19 below the water history. It is showing from 1984 up to 2020. Correct. So up 1984, 1995, 1996, and 1998, sorry, 1986 and 1987, 1989 and 1989. There is no water history because that time the satellite quality was not so good. So they did not find a good result. So that's why this is okay. It is showing just like click something and you will get the valid observation and water project history. You can see. Similarly, if we are going for the this that, top means here this one water occurrence, then water occurrence change intensity. So water occurrence change intensity. What it is showing here, it is showing water occurrence change intensity. There are red and green. Red and green. It is here again. You will find that valid observations, and then you will get the water reoccurrence. Again, here you have permanent water and then seasonal water at that particular point. Have that particular point. The history it is showing here. Then you have a water. How? Just I am taking the near this in Corvette National Park. Somebody wants to study that how this Corvette National Water or this water body is basically helping the wildlife reserves. Correct? Because in this area, this is the Sarai area. If you are going for Sariska Tiger Reserve, so in that area you will find that tigers are very, for tigers it is very difficult to touch the water. So in that case, you can link this study with your biodiversity also. So this is like if you are just click, basically you are clicking left click. Again you will get the so for month for different year for different months you will get the history. To play with this, okay. Have the seasonality. Have discussed the water seasonality. Then we are going for the annual water reoccurrence. So what is the meaning of annual water reoccurrence? We have developed, we have already just like how often was an area flooded by water from one year to another. And whatever you get that information of that particular year to year value. Will get permanent means permanent means what? Like if you have constructed the dam or you have constructed the reservoir, so that reservoir, the water is the reservoir is basically what? It is going to store the water, and when it is going to store the water, so nearby area is going to be flood, like getting the permanent status of storing the water. Okay, so that's why this is called new permanent. Lost permanent means it is completely lost. Seasonal, as we discussed that, it is changing the season. New seasonal means like they are becoming new part, like this area is getting new. This area is getting new seasonal. Lost seasonal, the color which is telling you the lost seasonal. Then you have a seasonal to permanent. How the seasonal to permanent, the water body is changing status from seasonal to permanent, and how permanent to seasonal. This is also basically permanent to seasonal means it is very like sometimes you will find that this will create a drought here, and seasonal to permanent if the water body is seasonal and it is going to be permanent, it creates the what? It can somehow either it is creating the badland or it can also impact upon the flood scenario of that particular area. So you have to understand like seasonal to permanent as if you are converting from seasonal to permanent or permanent to seasonal. Because we have to, if the water body is in nature no, we have the water body. If the water body has the permanent status, then it is fine. If we are changing the status of that water body without doing any scientific investigation, then you will find that whether you are going to for you are going to become prone for the drought or you are going to prone for the flood. Correct. So again, here you will find in the background layers you can use the earth time lapse. Lapses are there. You see how their time lapses are changing. Okay. Then you have a world map. Just do world map. Then you have a satellite images which will tell you the different scenario. What white basically background you can. Yes, so this point, yeah, just up to this. Now I am just by platform to argue. Is visible? ArcGIS interface. So I have downloaded two. Here, can anyone tell me this raster data source does not have pyramid layer? So what is the use of pyramid layer? Why we are going to create the pyramid layer? Or easy display. Once you create the pyramid layer, then there is a auxiliary file. Get auxiliary file, and then again you will open that file. It takes less time for opening. That's why we are going to create pyramid layer. Okay. So I hope all of you have downloaded. Have you downloaded? Hello.
So which one is the second you have to download?
Second. Second is
Yes, the
for
first one is occurrence.
first one is your occurrence. You have downloaded the occurrence. Second is your, then you just go down. So there is written a supporting file. Correct.
Sir, in symbology.
Yes, in symbology there is written data set. Correct. QGIS and then ArcGIS. Fine.
Yes, sir. Yes.
So if you have downloaded the first file like occurrence, for occurrence there is a symbology file occurrence.tif there. If anyone have downloaded the occurrence change intensity, fine. Up to this point it is fine. Hello.
The second file I have downloaded seasonality.
That is, then you have to download the severity.tip.layer. If you are using the RGIS, if you are using the QGIS, then you download the severity.q.
वॉइस बीच में क्लियर नहीं आ रही सर।
सर वॉइस
Sir,
क्लियर
your
नहीं आ रही सर?
हाँ थोड़ा सा आप, हाँ इस अभी क्लियर आई है। लगता है माइक इधर उधर हो रहा है क्या? माइक को अगर सामने
सर माइक यार
हाँ
इसको,
अभी ठीक है, अभी
अच्छा
ठीक
चलिए
है।
मैं हाँ ठीक सर, मैं समझ गया। ये एक्चुअली क्या हो रहा है ना, हिल रहा है
हाँ,
एक्चुअली थोड़ा माइक। या
माइक
नाउ
की
इट
ही
इज फाइन।
प्रॉब्लम है।
जी 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 सर, सेकंड माइक चेंज किया था मैंने। सो you have downloaded occurrence, then you have downloaded the seasonality, correct?
Yes,
I will
sir.
suggest you should also download the transitions.
Okay, sir. The file which are under section ArcGIS, those files, no, sir?
Yes, if you are using the RGIS, correct?
Okay, sir.
If you are using the QGIS, then you have to download the QML file. Okay. So I hope everyone had downloaded at least two files of data and two files of symbology. So everyone has downloaded minimum two files of data and two files of symbology.
So it
Hello?
is showing some options to open in Notepad or Paint.
No,
And,
just up to that download process. You have completed the download.
yes,
Download
sir.
had, yeah, okay. So no need to open in the notepad. So now you just follow my steps. You have just recall your data, or you have added your data. So either you can use through the plus sign, add the data, or you can add directly through the catalog. So catalog, from catalog you can directly drag and just I will remove, then I will show you. You can directly drag and drop. Okay, this data it is showing. So if you see in the basically right, okay, in the right bottom there is a dense network of rivers. So you can easily understand this is for the Bangladesh region. But if you see here, like in the northern region, you will find that Ganga course of Ganga is basically it is coming from this, and there is a dense river course which is coming from the Assam region to the Bay of Bengal side. So that is the Brahmaputra, and that is the Ganga, and here you will find some other river networks are there. So if you just there is a one plus sign is there, you can just click on plus sign, you will find that there is a lots of values are there. Okay, and how these values? So as I told you that you read the user data like guide, that one, user guide. In the user guide you will find that occurrence, the file, the occurrence, which is the data type is unsigned 8 integer 8. Okay, so upon that, based upon that, you will find there are some 0 to 255 values are there. Agree? Agree with this point, from 0 to 255, because the data is in the 8 signed, 8 unsigned byte. Up to this point it is fine. You just drag your data or you just add your data on RGIS platform. Fine. Now I am going to add the second layer, which is the symbology layer. I again using the drag and drop. Okay, when you use this layer, so it will ask like what is the source, on which source you are going to basically develop your symbology. In symbology, what is written, like it is written from not water to 100% water or no data. Correct. So not water means that that is not a water body, and from 100% means that remains the water body. And with this gray color, it is showing that no data, because the data is mapped over the land surface. So this gray here, if you are aware with the area, okay, it is showing the ocean. So over the ocean it is not considering the data, so that's why it is showing that no data. So just I am showing like just for your visualization I am changing, so you can easily understand that what in symbology, basically, not here actually. So it is showing that there is a one red marks. Okay, there is one red symbol is there. So what it is showing? It is showing that upon which you are going to develop your symbology. So again, like first one is, again you are going to use your data by which we have added. We remove this one. That was just for your visualization, like the data, what is the data type was there. Now I was using your, okay, it is asking where it is, the data is there upon which you are going to develop your symbology. So I am just adding this data layer. It is showing occurrence. Now previously it was showing in the, anyone have observed what was the previous, what was written? No. Previously if you just open your drag your like open your data, or you are going to add your data, it is showing 0 1 2 3 4 5 6. Correct. So 0 1 2 3 4 5 6, and in last you will find 255. But if you are going to add your symbology, first since I am using the symbology, then I am clicking on this, the check sign, and then I am adding the data. Correct. So it is changing. Now it is changing in percent. No water to 1%, 2%, 3%, 4%, 5%, and 100%. Correct or not? You are following my basically instructions. Huh? Hello. Yes, sir. वो आपको समझ में आ रहा है बेसिकली कि क्या कर रहे हैं? You all are getting my like steps what I am doing.
Yes, sir. Yes, sir.
Huh? You are all are performing that that those steps.
Yes, sir.
Kiran Kumar ji, you are doing something?
Sir.
Are you performing the demonstration as given by Dr. Sudhir Kumar Singh ji?
Yes, sir. Yes, sir.
So please respond, because many times speaker asks and I am listening, its voice is also clear, then please respond, because response should come from the participant side. Otherwise, we feel that neither bias is reaching to you nor you are responding. It means you are not able to understand. So please respond. If you are listening him, please respond, because many times I have listened itself. He has, I am looking it. So that's why it is fine now. There is no disturbance. So if you carefully see stepwise procedure he is explaining, I think all of you will get the benefit out of it. And I am finding first time, and it is I am observing form, whatever you can say. Although I am not expert in this area, but certainly I am enjoying it. So I request all the participants, if you are listening properly, you please respond to the speaker. Thank you.
Thank you, sir. So I hope you just understand, like when you just open the data, you just open. Okay, you just drag your data from R catalog in your ArcMap. Then you will find that when you click on this plus sign, you will find that the data is showing in terms of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, like up to 255, because the data is in the 8-bit. Fine. So the use of symbology means we have to convert this 0, 1, 2, 3 into whether the data, like whether the water body is the occurrence is 1%, 2%, 3%, 4%, or 100% remains the water body. Okay, so first you just add the layer, your TIFF layer, symbology layer, then click on the sign which is showing check sign. Okay, then click on that, double click or click on that, then you will find that it is asking for which layer. So we have downloaded the occurrence, correct? Occurrence TIFF layer, and now we are going to open the occurrence data here. When we are going to open the occurrence data, so that time the data which is previously it was showing like 0, 1, 2, 3 up to 255. Now it is getting converted into, the data points are getting converted into 1%, 2%, 3%, 4%, 5%, 6%, like that. Clear? This point is clear, I hope. Correct?
Yes, sir.
Yeah.
Yes, sir.
So what is the meaning of 100%? 100% is showing that the permanent water representing in blue color. Correct? If you see the blue color, so you can find that these blue, my cursor are there. Where is my cursor? You will just follow. Like this one is. So if you see this one, okay, this one, and this remains like in the Bay of Bengal. This is the Bangladesh region, and this near this there is a issue region all. So you will see that if you zoom out, then you will find that in Ganga river, if you just drag, there is a what? There is a very contrasting things are there. You just see by looking on the color codes, you can imagine that over the period of over the study period, like from 1984 to 2016, 18, or whatever the data you have downloaded, like we have considered the data up to 2020. So in that case, if there is written 12%, so means from the study period, the water is getting remains what? Getting remains permanent only, or getting remains permanent only for 12 years. It is highly changing. Only you will find the water in the river main channel. Surrounding there is a sand and all those depositions, everything is there. Correct? So if you do these things, you will find that how the water is changing over the period of time, and how the water body remains permanent. Correct? Clear? This point is clear. So by just looking without going in depth, like what is happening, what is occurring, whether the water body is like getting heavy rainfall, less rainfall. So without looking on those things, you just imagine that like how the water body remains permanent, what area remains permanent, and what area gets getting changed. Okay, so means our question will be answered like in terms of where and how often did surface water occur between the study period, okay, between 1984 to 2019 or 2020. No, not water means the water, that the area that is the that there is no water body, and 0% occurrence, 100% occurrence, 100% this area, so that 100% occurrence two area. That is the water reservoir is there. Right? So if you just follow these steps, you will see this. Can anyone tell me while looking these two rivers? Can anyone name which one is Ganga and which one is Yamuna? By visualizing these things, you can understand. Yes, Ganga and which one is Yamuna? Because without going in statistics, visualization itself will give you a lot of answers. Correct? And what is
Yes,
this
sir.
reservoir? What is this reservoir? So, and second layer, we are going to download. Second layer, I am going to download so that you can understand the transitions. Just it takes like, as I suggested you, that you have to download at least 2 layers, and to maximum water extent you can download also. And I have already told you that the resolution 30 meter because data the cell size is 30 meter because the data was created based upon the Landsat 5, 7 and 8. So I have
Sir, can
downloaded.
you get from data?
Pardon?
Sir, irrigation channel, can you find from this data irrigation channel?
Irrigation
Also,
channel. Yeah, you can somehow you can get it. Okay. I will add another layer. I'm going to add.
Hello, sir, am I audible? Hello. Hello.
First I'm using transition pyramid layer. While I will remove transition layer. Again you see it is showing different color. Data is again from we call that one.
Sir, your voice
Yes.
is not clear, sir.
So I'm basically I'm not telling anything right now. I'm just
Yes, sir.
so I'm just suggesting that what you have to download one another layer that is water transition. Okay, water transition. When you see that one again, it is showing from 0 to 255. So I am using the for water transition. I am using the that layer what transition diff dot layer for creating the symbology, and I have created. Now right click and again I am using the transition, that one. Now you see, when you just open the transition, so at that time you will find that it is showing 0, 1, 2, 3. And when you open the symbology layer, correct? And then you recall your main file. The main file was your what? The water transition. Then you will find that the classes, these are the classes like not water. Permanent. Hello. Hello. Hello.
Yes, sir.
Audible. 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 So, मेरी आवाज आ रही है? I am audible to all of you.
Yes, sir.
So the second exercise for this again using the global surface water. Second, in that exercise, I have just opened the. File, transition file, which is then you just open your one layer, the transition layer, symbology. Then you see in that hot water, permanent water, new permanent. New permanent like what it is showing slightly dark green. Then you have a seasonal like this one, this water set here kind of water set seasonal. If you think on this, as the value 4, not water. Correct.
Voice is not audible, sir.
Voice is not audible.
Yes.
Now it is.
Now it is okay, sir. In
Now it is
between, it
okay.
is not.
Yeah, actually maybe some problem is there. So up to this, you all understand, like
Yes, sir.
yeah.
Sir, what is meant by new permanent, sir?
New permanent, as I told you that if you like there was previously there was no reservoir. Okay, when you have created the reservoir or you have created a dam, what dam is going to store the water over the period of time, the water is getting stored and that remains means it is not like changing, the area is getting submerged, correct? So
Yes, sir.
that
Okay.
area is called as new permanent, or the river is going to change their course. If the river is going to change their course, that is also getting new permanent. Fine. So
Okay, sir.
then you have a seasonal, then you have a new seasonal. So new seasonal you are getting light green. Or fine. So these are the new seasonal. Then you have a lost seasonal, means seasonal water body. You have lost the seasonal water body. Then you have a seasonal to permanent the water body. Previously it was seasonal, now it is becoming the permanent. And then you have a permanent to seasonal. Fine. So how the permanent water body is getting seasonal, and then it is going to be what? It is going to be completely lost. Then you have a ephemeral permanent. Then you have a ephemeral seasonal. So this was the first one was your water occurrence. Second one was your exercise was your for water transition. One more I will show you. Then we will go on the exercise. So I request to all of you kindly do this exercise by yourself. So you can easily understand. Now I am just opening the extent data. So this is for your extent data. Again, it is read it, you will find that it is showing from 0 to 255. Clear? What we are basically discussing the extent. Correct? So extent, what is the meaning of extent?
Reference catchment region.
Yeah. The maximum water extent means provides information on all locations ever detected as water over the past, whatever the, because we have the period from 1984 to 2019 or 2020. The maximum water extent provides information on all the locations ever detected as a water over the 37-year period. Correct? So maximum unit. So in this you have a three class. One is your not water, water detected, and then you have a no data. So now what we are going to do, we are going to use the layer. For this I am going to use the extensive. I am using the extent data layer. Right. Now it is showing only not water. We just do this one. Now it is showing the not water. It is, if the this one, this is not a water. Okay, this white no water, not, that is not water. Then you have a this pixel. It is showing affiliated kind of thing. It is showing that water. Okay. Then no data. No data means gray points are there. Fine. Data is there. So clear? Up to this point it is clear?
Yes, sir.
Okay. So we have occurrence, we have change, we have seasonality, we have reoccurrence, we have transitions, we have maximum extent. Fine. So based upon that, you can go for the history also. History of that any particular, not any particular point or any particular water body. You can get the history of any particular water body also. Okay. So you can use the history if you are, if you want to study the history of that water body for the last 37 years. Okay. So you just download that history file of that particular area and then you go for the analysis. So this, it is clear. I hope it is clear. Hmm? Clear or not?
Yes, sir.
Up to this point, I think it is clear. Hmm?
Yes, sir. Yes,
So
sir.
yeah. So I request to, yeah. So I request to all of you, kindly do this exercise by yourself whenever you have time. Or if you have any question or comment, you can just ask. We have five minutes, like what, we have 5 minutes discussion on this particular point, that we can understand like need of this data set, how we can use this data set for our scientific investigations. Just I have first you have to Google the global and global surface water explorer. Then there is a explorer button is there. You can just click on explore. Downward it is when you just scroll downward, you will find that there is another scroll. Means first you click on explore, then you click on another explore, then you will get the you will get an window will open, and that window shows water occurrence from 1984 to 2020. Then you have a water occurrence change intensity. Then you have water seasonality. Then you have a water reoccurrence. Just there is one icon is there, so you just read. Just click on that icon. You will get the information like what is the meaning of water reoccurrence. Okay, and how the data was created. Fine. So everything is there. Then you have a water transitions are there, and maximum water extent is there. Just click on any water body. So they did not perform. Yeah,
That's sir.
yes,
That's
sir.
sir. One
Yes,
of the
sir.
participants has asked where is the history file. Please give the location.
Okay, okay, sir. So
Shima
history.
is one of the participants.
Yeah. Yes, yes, sir.
History.
Yeah, yes. Just a minute. Uh, I am just connecting again. Yeah. Okay. So this study area is near Kangra, or you can say it is visible. Talwara is there. Okay. So I am just clicking on one point. You find that there is one pinpoint is there. Okay. So it is I because I open the that time first I have water occurrence. Okay. So you will find in the bottom there is water history of that particular point because I have taken in between. Just I have taken the away from that like just water bodies like just I am taking this point. Okay, so that you can easily see what is the history of that point. This point. Okay, correct. So here you will see the history, so you can easily understand. Actually, depending upon the internet speed and this, like I am coding temporal file. Whatever the files you are selecting, like water reference, water your transition, here you will get the showing the on the layer water occurrence.
Hello,
Hello.
sir. One doubt, sir.
Yes.
Sir,
One.
this water occurrence
Yes.
or whatever the data, can we get in terms of volume? It is showing in percentage.
No, you will not get here in terms of volume actually. For
Okay, sir.
for getting the volume data, there are other websites are there. From there you can get the volume data.
Okay, sir.
I don't know why it is taking a lot of time for generating the loading temporal profile. If you just, I hope you
Hello.
just click on your, yeah, hello, you are getting the history. On my system, it is showing the load. Yeah, it is not visible.
No, I mean in the history it is not loaded, I think, in your system. Hello.
Yeah, hello,
Sir, it is loading
hello.
in your system. It will take time.
Oh,
Hello, am I audible?
yes, you are audible.
Sir, it is taking time there. And I have one more question.
Okay, yes.
Sir, this is only for rivers on rivers data, only water body data. Means if I want to see some water soil moisture data excess from this, I can't do that.
No, from soil moisture,
This is only
there
for
are
river.
other. This is only not only for river. You will get the information related with your wetlands, with your water reservoirs. Okay,
I mean water body, whole
and
water body part only, not for land.
yeah, yes. And
Okay.
for soil moisture, you have to go for this like SMAP, soil moisture. Okay,
Hmm.
SMAP,
Hmm.
SMAP products are there, and somehow you will get some
Yes.
data from the gray satellites also.
Okay.
I don't know why
Actually,
it is.
my work
I
will be
don't.
on
Yeah.
agricultural drought. So, so I was asking, can I use somewhere there? But I don't think so because it is showing only for wetlands or water bodies.
For drought, actually, you
Yeah.
can, because if you know the history of your water body, like the area, whether it is irrigated through river system or it is irrigated through canal or it is irrigated through your reservoir. Fine.
Hmm.
So if the
Okay.
water history is showing that it is changing, the water basically transitions or water seasonality is changing. So somehow you can correlate that if the water seasonality is changing, so it means
Hmm.
somewhere it is affecting your agriculture pattern. If there is a surplus of water in your system, okay, then it directly it
Hmm.
is related with your irrigation pattern. You can easily irrigate with your crop because in
Yeah.
India mostly people are relying on the subsurface,
Irrigation.
subsurface water
Uh,
irrigation they are doing. But
yeah.
government is promoting the surface water irrigation. Correct?
Hmm.
Clear or not? Because we are promoting the
Okay,
surface
sir.
irrigation.
Yeah.
Yeah. So
Hmm.
people are using actually.
Okay.
I do not know why it is not loading temporal profiles in my system. But if you see, maybe in your system it is loading. Correct? So in
Okay,
that
I'll try.
case,
Yeah. Thank you.
you just try. You people just try. So you will get the somehow you will get the history.
Okay. Okay.
Yeah, maybe
Okay.
to the internet or something
Thank
like.
you.
So, any other
So,
question? Yeah.
So I have downloaded the temporal profile for Prayagraj, but it's showing no water from 1987 to 2020. Why is it so?
1987 to
2020,
2020.
it is showing no water.
Which layer you have downloaded?
The temporal profile for Prayagraj.
Temporal profile for Prayagraj. Correct. So the file which we have basically downloaded, in that case you have seen that there is a river network is there. Okay. Because when you go for global database, correct, when the global database is there, so you will find that what people are doing actually when they are developing the global database, they are somehow what, because you need a validation also, you need to validate with your field. Correct. if your water body is very small, we are saying that we can map up to 30 meter, but that 30-meter pixel is not basically somehow you can say that there the minimum mappable unit is not 30 meter actually, correct? So in that case, if the water body is less than 30 meter or it is somehow it is around 30 meter, so it is very difficult to map. These are the some lacunas you will find in your global data sets. So still people are developing their data set up at 10-meter level, correct? When you read some articles like global data of 30-meter resolution, then you will read the global data of 10-meter resolution using optical data. So you will find that there are some adjacencies, rules are there. So those rules are violated when you use this kind of when you generate this kind of data set. So maybe, but you will get the river network is there, and some water bodies are there, some paleo channels are there, correct? Some oxbow lake patterns is there. So because I am seeing that one in my data actually. Prayagraj region, you are telling that in Prayagraj region we are not getting the, but in Prayagraj we are getting. Huh? You see when you open that Prayagraj is where? Yeah, there is a contrasting actually convergence of the river network. Contrasting convergence of river networks are there. As I asked that question also, can you identify the in that slide in that basically demo I asked that can you identify which one is the Ganga and which one is the Yamuna, and why the water body is showing dark blue or some water bodies remains very like very what throughout the year they are remains the permanent, but some rivers are getting dried when you go when you see those rivers the rivers which are originating from the Madhya Pradesh or in Odisha, small rivers are there. They are basically not a permanent. They are seasonal. Ephemeral rivers are there. Ephemeral water bodies are there. If you see the water reservoirs, so they are getting permanent. So I do not know basically which data set you have downloaded. Which one you have downloaded?
So I'm actually looking at the temporal profile one on
Temporal
the first page.
maybe the site actually because we are using this site. Maybe this is due to the the server actually problem maybe. But you will get the history you will get, okay, history and everything temporal files are, because currently I do not have the sample, but I will load temporal file. So it is basically not buffering also, so maybe we
It is
continuously we put, yeah, tell me.
it is written background layer, Earth time lapse, world map, satellite fight. Can you explain this one?
Yes, actually it is showing that this now earth time lapse means from 1984 to this one, it is written on bottom 2016. Okay, beyond 2016 we will go Google Earth. When you click on world map, then it will show the world map. Then when you click on satellite, so background you will get the satellite images are there. When you click on white, so you will get the background white. So for that purpose, visualization purpose.
Oh, okay. That is
Okay,
fine.
later on you will try. You will get the your temporal profiles and see the temporal profile in the below panel. You will get the water history and water history, annual water history. When you click like 1987 and when you go for 1997, then you can click. So you will get the in 1987 in the month of July. Then you click on 1997 in the month of July how it is changing. Okay, so that temporal profile will tell you the history of any region. Fine. Any other question? Any other question?
Yes, sir.
So question you if you have any question you just ask.
Sir, where can we download? It is just showing for the points, this history data. There is no option to download.
Yes, actually, that is the issue. Hmm. You can just save as a
So this is
picture.
just for visibility.
Yeah,
Okay,
that is you
okay.
can save as a picture also.
Okay, fine.
But later on, you can download that one.
Okay.
Because that's why I'm telling. If we will write the people, those who have developed the data or the agency, if we write or we ask them to develop a plugin or to basically to download the water history directly temporal basically water temporal profile, so they will basically what they will develop that one. If we will not use that their data, if we will not write them, so these people will think that nobody is interested in using this data set, so why we are going to invest the money, correct? So that's why whenever we are mostly like in India, people don't write to agencies. They simply understand that if this is not available, okay, fine. But we have to write them so that they can put put in front of their what in front of their scientific team to develop the to develop the product which can be easily downloadable and which can be easily usable also. Fine. So that was our objective. So now, how many of you have worked on this what we called it arc scene in ArcGIS? How many of you have worked on arc scene? 3D analyst arc scene.
And Pushpa Sahu is raising the hand. I think she has seen it
Okay, sir.
because she has written that her speaker is not working. I think sometimes
My speaker,
showing.
sir.
No, no, not your speaker. Then Pushpa Sahu has seen the arc scene, as you have said. Ask the participant.
Yes.
Has raised the hand. Yes, she has seen.
Hand. Okay, okay. So so majority of people have not seen the arc scene. Okay. Or they have not worked on arc scene. Fine. So I will show you one case study in terms of using your arc scene for your flood visualization. Because as I told you that we are not using any study or non-study model for flood forecasting. We are just first
मैडम
we
आपकी
are just
स्लाइड
using.
हैंग कर गई है क्या? स्लाइड हैंग की है या कुछ और अभी
सर
स्लाइड को
सर
आप नहीं
स्लाइड हैंग नहीं किया सर, अभी मैंने वो क्लोज कर दिया है सर, वो जो उस पे चल रहा था।
लोडिंग
तो
टेम्पोरल
अब मैं
प्रोफाइल इसी पे आ रहा है।
अच्छा सर लोडिंग टेम्पोरल प्रोफाइल, बट वो लोड ही नहीं हो रहा है सर।
हाँ हाँ लेकिन वो आ रहा है, उसको हटा दीजिए।
हाँ सर वो मैं हटा देता हूँ सर। किस काइंड ऑफ बेसिकली प्रोफाइल वो जो अभी दिख रहा है सर?
हाँ अभी भी दिख रहा है।
ये एक ठीक सर, मैं इसको हटा देता हूँ सर, है ना?
हाँ हाँ हाँ
स्टॉप शेयरिंग नाउ। ठीक सर। सो फर्स्ट वी हैव टू ओपन दी ArcGIS. So for this exercise, you have already, if you all have already the DAM data, then it is fine. If you don't have the DAM data, then also it is fine. You just follow my steps and later you do at yourself. It is very easy.
Sir, we are unable to see your windows. This one, ArcGIS.
You will just you will get this one. Okay.
No, sir. Still, it is showing loading temporal
Yes. But
profiles.
still it is showing temporal profiles loading.
Yes, sir. Same
But I
window
have
it is showing.
stopped that one. Again I have. Now it is stopped sharing.
No, sir. Still it is same window.
How it is showing a window? Actually, I do not know. Now
No, sir.
it's still showing window.
Yes, sir.
How it is like?
Sir, you have shared full screen or particular window?
I am sharing the. Oh, just a minute. I am just sharing this one. Now you see.
It's not visible still.
No, sir.
Okay. Eh, Vikram, देखो जरा इधर आओ. Now it is fine.
No,
Hello.
sir.
No, sir. So I suggest please close your unwanted tabs.
Wait for 2 minutes. ये क्यों नहीं शेयर हो रहा है देखो. नहीं स्टॉप प्रेजेंटिंग कर दिए. कर देना. कर दिए. है. वैसे ही. बैकग्राउंड यहाँ से क्या होता है ना इतना बनता नहीं है. Now it is fine. Or is still
No, sir.
showing?
Still, sir.
Still showing.
Yes, sir.
Why it is happening? Yeah. I will reconnect it. Okay.
Okay, sir.
It will be better, Dr. Saab. Please reconnect.
Yes, sir. Yes, sir. So you can download your DEM and you can just open your DEM. Fine. Then what I did, I have first open the DEM. Okay. Like this way. I have opened the DEM. Then I have just opened my study area site. This is for your Ghagra River Basin. I have just opened the Ghagra River Basin. Fine. This is the boundary of the Ghagra River Basin. If you can just make your boundary in this way, or you can develop you can make your boundary in rectangle form also. You can. So my boundary is like this way. This is for Ghagra River Basin. The river Ghagra is originating from the Himalayan region in Nepal, and it comes to in the Indian region. So then what I did, you all know the basically dam profile. This is the dam profile. Sorry, dam not dam profile. Basically, that is the dam symbology. So, and I am just developing this. And this one is your that one. So you see the dam elevation. The dam elevation ranges from 1 meter to 8,188. Okay, the dam, there is a high variation from the what? This elevation is from what? Can anyone tell me what is the reference surface actually? This one. I will suggest you one book actually, that is like in digital elevation model, we have three words. One is D and second is E and third one is M. Still people are debating what is the meaning of D, whether it is digital, data is digital, and second is elevation, and elevation from which reference surface line. Okay, and M still controversial, whether basically we are using the M for method on the what method basically people are used for developing the digital elevation model, correct? So still M is very, like we call, we in terms of science, people are still debating what is the meaning of M. So digital elevation model, many of you have already studied, or you have already worked on that, but still you will find that D is very, many people are agreed, many scientific communities, scientists are agreed upon what is the meaning of D. E also they agreed, but still on M, whether you are using the which method, depending upon the method of gathering the systematic information for generating your elevation model, means digital elevation model. Okay. So based upon that, you will find if I am using the ALOS dam 30 meter, if I am using the SRTM dam 30 meter, if I am using the Cartosat dam 30 meter, so, or I am using the any like Merit dam, or nowadays you will find Tower dam is there, NASA dam is there. So what basically method they have adopted for generating the digital elevation of any surface, correct? So this, it is showing that from 1 to 8,188 meter. If the area same, if you are having the same study area,